Okay. Now, here we have a situation wherein we have 500C92 is equal to 499C92 plus NC91. If you see, there is a connection here. 500 is one more than this, and this is the same. So it's like telling NCR on this side, this is N plus 1 CR. So, but we can either connect these two accordingly and get this, or we need to do it accordingly. Now, we can possibly split up 500. We know that N plus 1 CR plus 1 is nothing but NCR plus NCR plus 1. That means 500C92 can be written as 499 C92 minus 191 plus 499 C91 plus 192. So here we can use this formula. So the left hand side turns out to be this. Right hand side we copy down as it is, 499 C92 plus NC91. So 499, this 500 C92 is written as 499 C91 plus 499 C92. That is N plus 1 CR plus 1 is N, that is 1 less CR, that is 91 plus NCR plus 1, that is the same as this. Right hand side remains as it is. Now here these two terms are getting cancelled. So we have 499 C91 is NC91. So therefore N has to be 499, and hence the answer in this case is 499. So this is what we get as the option, and yes, it's tallying with what we have. Okay. Now again here we have 1000 C98 is equal to 999 C97 plus XC901. Much the same way this one also, 1000 C98 can be written as, this is R plus 1. So this has to become R. That is 999 C98 plus 999 C97. So it's sort of form NCR plus NCR plus 1, which will turn out to be N plus 1, that is 1000 CR, that is 98, left hand side. Right hand side is 999 C97 and XC901. Now, find X. Now, if you see here, this and this gets cancelled, so you have 999 C98 is equal to XC901. Now, in the previous example, we equated the R's, but here R is not equal. But here this 901, if X becomes 999, then this 901 can be written as 98. So we can write this, we can change this. Suppose you take X as 999, this 901 can be written as 999 minus 98. So 901 can be written as 999 minus 101, and this 999 left hand side remains as it is. If now it's quite clear that x's have to be equal. In that case, this 901 can be written as, we are using the rule NCR is equal to NCN minus R. So R in this case is 901, N is 999. So this same 901 can be written as 999 minus R minus 901. So 999 C98 is equal to 999 C. 999 minus 901 is 998. That means this X has to be 999, so that these two are equal. So thus we get X as 999. Thus we can solve it this way. So it's based on the same principle that this becomes 901. If this Ultimately, you are left with 999 C98 is XC901. And this is possible if 901 can be written as X minus 90. Or there is another way of doing it. We can write it this way, 999 C98. And this can be written as XC X minus 901. We can even equate this way. So even in this case, you can say X is 999, or you can equate X minus 901 is equal to 98. This will also give X as 999, and this will also written X as 99. So we can equate it in this way. XC901 can be XC X minus 901 using this particular formula, and you get X as 999. Thus we have this, and yes, that's valid. Okay, now we have this case 2n factorial can be written as what among these? 2n factorial, if you see, is nothing but 2n into 2n minus 1 into 2n minus 2 into 2n minus 3 into 2n minus 4 into 2n minus 5 into 2n minus 6, and so on and so forth. And finally it is 5, 4, 3, 2, 1, and so on and so forth. Now in this, collect all the odd. This will be the same as 2n into 2n minus 1 into 2 into n minus 1 into 2n minus 3 into 2 into n minus 2 into 2n minus 5 into 2 into n minus 3 5 into 2.2, 3, 2, and so on. Now you collect all the 2 terms. If you see, there is 1 2 here, there is 1 2 here, 2 2 2. So ultimately all these 2's on multiplying become 2 raised to n, because there will be n such 2's multiply result, and you will be left with n, this n, then there is this n minus 1, there is n minus 2, there is n minus 3, and so on and so forth. And there is 2n minus 1, there is all the odd numbered ones, 2n minus 3, 2n minus 5, and so on, and 5, 3, 1. This is the way it works out to be. So it's 2 raised to n. If you collect all the even number terms like 2n minus 2, 2n minus 4, 2n minus 6, you can take out 2 as a common factor out, and all these 2's which are from the even numbered ones become 2 raised to n. N minus 1, n minus 2, n minus 3 will come together this way, and the remaining 2n minus 1, 2n minus 3, 2n minus 5 will work out to be this. Now this will turn out to be n into n minus 1 into n minus 2 into n minus 3 would be n factorial, and this would all be, you can write this way, 1 3 5 2n minus 1. So it's eventually 2 raised to n into all this into n factorial, and among these, this is the option, 2 raised to n into n factorial into 1 into 3 into 5 up till the 2n. That means it is a product of 2 raised to n into n factorial and the product of all the odd numbers that we have. So among these, option A works out to be the right option, and hence we get it accordingly. Right. And this, of course, we did earlier, the rule NC1 plus NC2 plus NC3 is nothing but option. This is a rule NC1 plus NC2 plus NC3 plus NC4. Eventually it becomes 2 raised to n minus 1. So, yes, that's what we get it. Okay, now coming back to these sums, 6 PR is 24 6 CR. Then find R. So 6 PR is nothing but 6 factorial. Remember, 6 PR into upon 6 minus R factorial is equal to 24 into 6 factorial upon r factorial into 6 minus r factorial. So here 6 gets cancelled, this gets cancelled. So r factorial is 24. If r factorial is 24, we can write 24 as 6 into 4, which can be written as 2 into 3 into 4, which is the same as 4 factorial. So r factorial is 4 factorial. So obviously r is equal to 4. And as it is, we know it's 4 factorial, which is 24, and hence we get 4 as the solution for this. And we have that. Okay. Here we have a situation NPR is equal to NPR plus 1 and NCR is NCR minus 1. Then find the value of n. This again is a pair of simultaneous equation. NPR is NPR plus 1, that is n factorial upon n minus r factorial is equal to n factorial upon n minus the whole of r plus 1, that is r minus 1 factorial. This of course gets cancelled. So now this means that n minus r factorial can be written as n minus r into n minus r minus 1 factorial is equal to n minus r minus 1. So we have invertendo we have used. 1 upon n minus r factorial is equal to 1 upon n minus r minus 1 factorial, is the same as this. And this inverse of this, which can be written like this. So ultimately n minus r is equal to 1. This is the first equation we get. And NCR is NCR minus 1, that is n factorial upon r factorial upon n minus r factorial is n factorial upon r minus 1 factorial into n minus of r minus 1, that is n minus r plus 1 factorial. So this of course gets cancelled. R factorial can be written as r into r minus 1 factorial. N minus r factorial will remain as it is, r minus 1 factorial. This can be written as n minus r plus 1, and the next one lesser than this is n minus r factorial. N minus r plus 1 into n minus r plus 1 minus 1 factorial, that is n minus r factorial. So n minus r get cancelled, this and this get cancelled. So r is equal to n minus r plus 1. In other words, n minus 2r is equal to n minus 2r is equal to minus 1. This is the second equation you get. 1 minus 2. 1 minus 2 gives minus r minus of minus 2r. R is turning out to be 2. R turns out to be 2. Substitute in 1. So you get n minus 2 is equal to 1. So n would be 1 plus 2, 3. So if this condition is satisfied, that is if NPR is equal to NPR plus 1 and NCR is NCR minus 1, then the value of n is 3. And of course, it will help if we say R is also 2. So the value of n is 3. And yes, it is 3 as per how we verified. Alright, then we have n plus 1 factorial is equal to 20 into n minus 1 factorial. Now n plus 1 factorial can be written as n plus 1 into n minus 1 factorial. N plus 1, the next number lesser than this is n, the next is this, is equal to 20 into n minus 1 factorial. These two can be divided. This will give n square plus n minus 20 is 0. On solving this, you get n is minus 5 or n is equal to 4. So either n is minus 5 or n is equal to 4. N is equal to minus 5 is of course not valid because n has to be a positive integer. So our correct answer is going to be n is equal to 4, and hence n is equal to 4 is the correct option. So these are all simple solving of equations, obtaining quadratic equations. If you have noted in all the examples that we have come across, we have taken care as to how we can do away with the factorial process by taking the numbers, trying to factorize n plus 1 factorial in such a way so that terms get cancelled on both sides. Anyways, the value of n in this case turns out to be 4. Okay. Now, we have 15C3 plus 15C3 is equal to what? So here it is NCR plus NCR, which can be written as n plus 1 CR. So in that case, it is going to be 15 plus 1, 16C3. It's going to be 16C3. So among these, it's going to be 16C3. Yes, and we do have it. We're using the same formula, NCR plus NCR plus 1 is n plus 1 CR plus 1. But here both the R's are equal. So both of them are equal. So that itself can be taken as the common value of R. Okay. Now here you have 13C6 plus 2 times 13C5 plus 13C4 is nothing but 15CX. Now, there are various ways of doing. Among these, I would suggest this 13C6 we have. 2 times 13C5 can be written as 13C5 and one more 13C5 plus 13C4. Now we can combine these two and then these two. Here you're using NCR plus NCR plus NCR plus 1 is n plus 1 CR plus 1. So n in this case is 13. So it's going to be n plus 1, 14. This is R, this is 14C6. Plus, here again, NCR plus NCP. So this will turn out to be 14C. Among these two, the bigger power is 5, 14C5. So these 4 terms on simplification become this. Again, you're using NCR plus NCR plus 1 is n plus 1, 14 plus 1, CR plus 1, that is 55 plus 1, which will be 16C6. So the left hand side works out to be 14 plus 1 is 15, I'm very sorry, 15C6. So left hand side is 15C6, right hand side is 15CX. So it turns out to be, X turns out to be 6. So among these values, X will be equal to 6, and yes, we do have it that way. Okay, after this, let's see what we have in line. Okay, you have one case, n minus 1 PR plus R times n minus 1 PR minus 1 is equal to what? Now, let's see, n minus 1 PR is nothing but n minus 1 factorial upon n minus 1 minus R, which can be written as n minus R minus 1 factorial, plus R times n minus 1 factorial upon n minus 1 minus R minus 1 factorial, which will turn out to be n minus 1 factorial upon n minus R minus 1 factorial plus R times n minus 1 factorial upon n minus 1 minus R plus 1 factorial. This gets cancelled. It's eventually n minus R. Now here, how can we do? We can write this as n minus 1 factorial upon n minus R minus 1 factorial plus n minus R factorial can be written as n minus R into n minus R minus 1 factorial. Numerator is R into n minus 1 factorial. Now here we can further simplify. In the numerator, we take it as this into this. Eventually it is n minus R into n minus R minus 1 factorial divided by this. This divided by this gives you n minus R into n minus 1 factorial plus r times n minus 1 factorial. This, on simplification, denominator is n minus r into n minus r minus 1 factorial, which is nothing but n minus r factorial itself, because it's like telling 6 into 5 factorial can be written as 6 factorial itself. So we get this. Here we can take n minus 1 factorial as a common term, and inside you get n minus r plus r, which will be n into n minus 1 factorial, which is nothing but n factorial upon n minus r factorial. So ultimately this whole thing works out to n factorial upon n minus r factorial, which is nothing but npr. So this works out to be this. So among these, it is this value which is the correct option. So we are just basically converting them to simpler terms. Once you get n minus r factorial, which can be written as n minus r into n minus r minus 1 factorial, you can skip this step, because in any case this is going to be n minus r factorial and hence we get it as npr. And yes, that's what we have.